An equation with this form is called a quadratic equation. One thing to appreciate about this equation is that we have an x squared rather than an x cubed or an x to the fourth or even a square root x. Equations with this form can be solved through the quadratic formula, which you see on the screen here. Something that's very important about using this quadratic formula is that we really do need a quadratic equation in this form, where, among other things, one side of the equation is equal to 0. In this video, we'll review how to solve a quadratic equation with the quadratic formula, but let's first quickly review how we simplify square roots, because that's going to be important as well. Here I have 3 square roots. Let's simplify each one of them. The square root of 49 is 7. You guys know this because 7 times 7 is 49. The square root of 20 is very different. 20 isn't what we call a perfect square. There isn't a whole number that when multiplied by itself leads to 20. Instead, with a calculator, you could see that the square root of 20 is an irrational number, a decimal which begins 4.47211359. But we will need to be able to simplify the square root of 20, and the way we do it is like you see here on the screen. The idea is to write 20 as 4 times 5, choosing this particular product because we want to use a perfect square. 4 is a perfect square because the square root of 4 is 2. So this gives us our final answer. Here's how we need to simplify the square root of 20. Now, the square root of a negative number is not a real number, because if you square a real number, you'll never get a negative number. That's because a positive times a positive is a positive, and a negative times a negative is also a positive. So instead we call this an imaginary number, and we use lowercase I to stand for it. So this will be important. We use I for the square root of -1, choosing I to represent imaginary. Imaginary numbers might seem like some boring, esoteric mathematical idea, but they are essential to the modern sciences, especially modern physics. This is one of my favorite equations. It's Schrodinger's equations. Notice the appearance of I. Imaginary numbers really are essential to the modern sciences. And they're important for this video and your homework as well, because we're going to encounter square roots like this. The square root of -4 is not a real number, but we can simplify it. Here's what we do. We express -4 as positive 4 times -1. Now we have something for the square root of 4, it's 2. And we have something for the square root of -1, it's I. Here's another example. And this is the one that's going to matter most for this particular video. -50 can be expressed as positive 25 times -1 times 2. The reason we're doing it like this is because we have something for the square root of 25. It's 5. We have something for the square root of -1. It's I. So here's how we're going to simplify these square roots when we utilize this quadratic formula. But remember, not all square roots can be simplified. Square root 26 is already in simplest terms because we can't express 26 as a product using a perfect square. We could obtain 26 from 4 times 13, but neither 2 or 13 can be simplified the way the square root of 4 or the square root of 25 can be. Okay, so with that quick review out of the way, we get to what really matters most for this particular video: solving an equation in the complex number system. So we have a quadratic equation. We're going to use the quadratic formula, but first we need one side of the equation to equal 0. That is absolutely essential. But we will use this quadratic formula. First, however, we're going to add 2 to both sides so that this negative 2 and this positive 2 eliminate, and we get this 0, which we absolutely need to use this quadratic formula. Now, in the quadratic formula, a is the coefficient of the squared term, which is 5. B is the coefficient of the linear term, the coefficient of x, which is 4. And C is the constant term, which is positive 2. We'll replace these variables, these letters, with these numbers. Negative b becomes negative 4. B squared becomes 4 squared. 2 times a becomes 2 times 5. 4 times a times c becomes 4 times 5 times 2. Now our job is to simplify this expression as much as possible. First, in the denominator, 2 times 5 is 10. Inside this square root, we have this 4 squared, which becomes 16. 4 times 5 is 20, and 20 times 2 is 40. Now, 16 minus 40 is negative 24. The square root of negative 24 is not a real number. This equation does not have real number solutions, but it does have complex number solutions, which we can obtain by simplifying this square root, like we just reviewed. The idea is to express this negative 24 as positive 4 times negative 1 times 6. Now we have something for the square root of 4 and something for the square root of negative 1. Square root of 4 is 2. Square root of negative 1, we're using I. We're almost done. The last thing to do is to simplify this fraction. We simplify a fraction by finding common factors and dividing out those factors. We need to recognize that we can cancel a 2. We can do that because 5 times 2 is 10, and from the numerator we can factor out a 2. So these 2's cancel and we get our final answer. This equation has 2 solutions in the complex number system. You should be able to type your answer into MyMathLab using this format, although sometimes it wants this format instead, where the plus or minus is there to indicate that there are 2 solutions, one coming from the case of addition and one coming from the case of subtraction.